back with our lectures. Today is From Bauhaus to Broadway. Enjoy! Whoa! This is a video that shows tubular steel being bent into an amazing shape by a computer-assisted tubing bender now. That's not what we're going to talk about this week. What we're going to talk about instead is the dawn of the era of tubular steel. I wanted to show you this video in advance so that you can have an idea of why this material would be so interesting and important while we talk about our clumsy learning how to use it. This week I'd like to look at tubular steel as a device for talking about the Bauhaus and as a way to explain some manufacturing advances in America that produced some pretty ugly things in the service of trying to achieve a more modern way of construction and manufacture. We're going to look at a lot of chairs. My apologies to those of you who don't like chairs. It's just the tool that gets us across the finish line most gracefully, and also, frankly, because the Bauhaus era was an era of a lot of architects designing furniture, architects like to make chairs, and that's what we're going to look at. Jim Hurd, who was the curator of the Bicycle Museum of America, said that at the turn of the century, 1900, there were two buildings in Washington, D.C. that held every patent that the U.S. had generated up to that point. One building held every patent for everything, and the other building was just patents for bicycles. It's easy to forget how prevalent and important and exciting bicycles were at the time because we live in a world where we have so many other methods of transportation that are more affordable and more common. These posters, I think, help explain how cross-style, cross-type of person, cross-activity, how many different barriers were broken down by the presence of the bicycle. You could find a bicycle poster in the Art Deco style, in the Art Nouveau style, and you could find all sorts of different people excited about using bicycles, designing bicycles, living in a bicycle culture. And bicycles, of course, all industrial designers love bicycles, but they're important for our story because they forced manufacturing to figure some stuff out that then designers could repurpose for other uses. The biggest advance would be tubular steel. Our ability to make metal into a tube wasn't new, but it took a big leap forward in the 1890s. The Mont-Stam process, invented by the Mont-Stam brothers, essentially takes a hunk of steel, drills a hole through it, and then rolls it over and over again through a series of die with a cone-shaped device inside to make it ever thinner and longer. So it's not extruded, it's a slug of steel turned into tubing, but that gave us thin-walled, even-walled, seamless tubular steel. If you add to that electroplating, you get tubular steel that can live outside in the rain better. This is a process we looked at, and we've looked at it a few times so far this semester. The 1820s, it was a new process, but it was battery-powered. And we talked about, with the advent of automobiles, the need for a coating on metal that was more resilient and more resistant than paint or enamel. Chrome plating is a really good surface to achieve that. And as you add electricity to the process of chrome plating, you can scale it up and get bigger and bigger plating facilities. The picture on the top shows 1911, and you can see they're wooden vats that are tar-lined, and it's a sort of a craft process. Very soon thereafter on the bottom, the automobile industry scaled that up so that you get automatic plating processes and larger tanks and bigger machines. With the advent of World War I, the aviation industry required all sorts of refinements and developments in plating as well. We got hard chromium plating, bronze alloy plating, nickel plating, and all of that can get used for other purposes after World War I. Last week when we looked at the Art Deco period, we looked at all sorts of shiny things that were shiny because they were chromed. And we got a better understanding of how chrome was used as a material. What I'd like to look at this week is how chroming on tubing leads to another sort of opportunity for designers. On the left you can see Bauhaus purity European design purity, and on the right, the American manufactured sort of bastardization of all of that. And that's what I want to do. I want to explain how that happened and why, and I have to ask for your patience because some of you will be frustrated by the stark purity of the first chapter, and some of you will be frustrated by the sort of ridiculousness of some of the objects of the second chapter. But the story I want to try and illustrate with these two chapters is how we took a conceptual purity of design that wasn't really manufacturable and learned to manufacture it, and in the process had to make some sacrifices. Some of that purity had to be thrown out to bring the price down and the quantity up. This is sort of like tubular steel behind the music. A couple of weeks ago we looked at the Art Nouveau period, and we looked at how, although the objects were all still decorated, the surface decoration was a lighter, more graceful affair than Victorian things had been. We used adjectives like natural, tensile, exotic, luxurious. And then last week we looked at the Art Deco period. When we looked at this slide, you threw out adjectives like geometric, speedy or fast, shiny. What we're going to look at right now are product from the Bauhaus era. If you were there, if we were having class tonight, you'd be shouting out all sorts of adjectives like undecorated and geometric and machine-made. And I'd be congratulating you on those excellent choices of adjectives. In reality, these amazing objects produced by the Bauhaus family of designers were meant to seem manufactured, and some of them were meant to be manufactured, but many of them could not be manufactured. They were actually hand-constructed and did not meet with great commercial success because at the time these were very forward-thinking objects and they were a little too harsh for most people's homes, and because they were handmade, a little too expensive. They did have an enormous impact on everything designed ever since. And one of the most important things to keep in mind is that the Bauhaus also introduced a lot of the ways we still educate designers. So for me, the objects are beautiful and tell a great story that we're going to look at, but keep in mind that as a school, as an educational effort, the Bauhaus is invaluable to us today. The Bauhaus has three phases. The first phase was in Weimar, in Germany, and I don't know if you remember Henry van de Velde, a favorite of mine from the Art Nouveau period and beyond. He lived for a very long time. He was head of a school called the Grand Ducal Saxon School of Arts and Crafts in Weimar, and in 1915, because he was Belgian and World War I was starting, he was asked to leave Germany. And before he left and stepped down as director, he proposed that Walter Gropius succeed him. That's when that school became the Bauhaus. Gropius transformed this sort of sleepy arts and crafts school into something much bigger and much more enduring. But in its first phase, under Gropius, it's still inherently craft-based. There's a very strong foundation of education being developed, and that celebrates all the things that freshman foundation programs still celebrate: color, form, contrast, the primacy of basic geometric shapes, unadorned surfaces, circles, squares, cones, all of that, all of the aesthetic of the Bauhaus comes out of that educational plan. After World War I, there's more need for commerce, for design and manufacturing to meet and produce objects that people could consume. And there are also some professors at the Bauhaus, Laszlo Moholy-Nagy and Joseph Albers, who get involved trying to steer Gropius in a more industrial direction. And the school starts to take a more industrial approach. In 1925, they moved to Dessau, to a purpose-built building that Gropius built. That's the picture on the right. And then there's one more sad chapter at the end. It moves to Berlin for a very short period of time after the Nazis are finally successful in shutting down all possible innovation. Because the Bauhaus is so covered in every other art history class you're taking, I'm just going to talk about the parts of it that sort of support my story and know that you'll learn more about it in other places from people who are better prepared to talk about it. There isn't a lot to look at from Walter Gropius for us as objects, because he was really an educator and an architect more than anything. But the things that he did produce show everything you want to see from a Bauhaus effort. There is a purity of form, a simplicity of geometric form, even in the pieces that were made in very limited production or one-of-a-kind pieces. You see that pursuit. We see some early work from Gropius, and then I have a funny slide of a late piece to show you. In between, he was mostly an architect and educator. I show this not because I want to celebrate it as a great design. I show this because it's an example of his much later work when he lived in America at the time. And I'm fascinated by the fact that this teapot has survived to the point where it's in almost every Chinese food restaurant you go into. It's unavoidable. It's like the Thonet chair. It's something you've never noticed, and now that you've burned it into your retina and your brain and your memory, you're going to see it everywhere you go. I don't think it's any sort of triumph of teapot design, but for some weird reason it has endured. Because we're in New England, I want to show you the Gropius house as well. I'm just going to put this one slide up as a placeholder to let you know that after he left Germany, he went to England for a moment, for a year, and then came to teach at Harvard and designed and built his own house as a celebration of the things he had been able to bring with him from Germany. So there's an amazing collection of furniture. It's all preserved as it was lived in at the time, and it's really worth a visit. So all of you who have free time, get in a car, get on a bus, go to Lincoln, Massachusetts, put on the little paper booties over your shoes, and take a tour of this sort of transcendently exciting, incredible, modern interior. I'd like to spend more time talking about some of the people at the Bauhaus who actually designed objects that can tell the story we want to look at. And the first of those would be Marcel Breuer, because he's really the one who started the ball rolling. On the left you can see a student piece of his. It's a wooden chair that he designed, and it has all the excitement of a student piece of furniture. It's full of energy and vitality, and it's wood being wood. Wood wants to be a rectangle and will let it. But it doesn't look very comfortable. It doesn't look very resolved in terms of manufacturing. And look at the chair on the right, a mere 6 years later. For me, it's one of the triumphs of thinking about manufacturing. And we'll look at the construction system of this chair in a moment. Legend has it that Breuer was walking to school or work one day and came across an Adler bicycle and marveled at the chromed, bent tubular steel handlebars and realized that that material and those manufacturing techniques could be used in any metal shop in support of any kind of investigation. And that opened the door to an exploration of using tubular steel to produce furniture. What I love about Marcel Breuer's work is that you can always find his thinking pattern by looking at his work. On the chair on the lower left, you can see a sort of clumsy corner where one piece of tubing is just screwed into another one, and the stretchers in the front below the seat are screwed in from the ends. And then the chair on the right, he's realized that you could actually introduce you could get rid of the back legs, and in the front you could introduce a different stretcher system. There's a traveling Vitra show of Breuer's furniture where you get to see all of the prototypes that lead to the final chairs, and it's really a revelation to see how each iteration answers a problem and perhaps introduces a new problem, and then he throws himself at solving that next problem. So if you look at all of his early work with tubular steel, you can see an exploration trying to figure out how to have the structure you need to hold a person up, and how to have the structure that you can build using the tools you have, but how to, by examining those things, end up at a brand new kind of support system and kind of chair. This chair, the famous, now called the Wassily chair, but at the time it didn't have that name, we call it the B3 chair. It's the most amount of chair and the most amount of form language and the most amount of energy and contrast between materials that you could ever get out of one chair. And yet, if we look at the parts that are used to make it, it's almost nothing. In fact, many of the parts are repeated on the other side. So it's actually only, I think, 6 parts to make this whole chair, which is remarkable. And that's a result of looking at, if I make the front leg turn into the armrest, I can solve that problem, but I introduce this new problem. Maybe the front leg turns into the stretcher underneath your legs, but then that digs into your under your legs. So maybe it's a stretcher that sits down farther and the seat is suspended above that. There are all sorts of problems being solved in the construction of this chair. My favorite Breuer chair would have to be this remarkable aluminum chair from 1933. It's very early for anybody to be using aluminum in production, but it's also very, very smart construction. It's an extrusion that is then sliced down the middle, and each half is bent in a different way. So one extrusion turns into the part that makes the bottom support, the arm support, the front support, the side of the entire chair. And you take those two parts, one for each side, and attach them with some stretchers that are just screwed on, and you have a chair. It's an awful lot of chair visually, but it's almost nothing structurally. This is the patent drawing for this chair, and I think it's interesting to look at patent drawings from this time period because Breuer didn't really know how he would end up solving all the problems, but he wanted to patent the basic concept which started him down the path. So the patent drawing shows every possible outcome he might ever arrive at on one page, so that wherever he went, it would be covered under this patent. And I've blown up the section at the bottom, which is the profiles of the actual extrusions. You can see the fourth down on the left that has the sort of three grooves. That's the closest to the one that ended up getting used. That's extruded in aluminum, and then is just run over a bandsaw down the middle, and you get these two separate channel grooves. Here's a picture I took at the Milwaukee Art Museum just a couple of weeks ago when I was there that shows you, as well as I could without getting in trouble in the museum, the back leg, the extrusion, and then you can see the point where it starts to get cut, and the left-hand side bends up and becomes the armrest and twists around and attaches to the back support. And the right-hand side continues all the way around the outside of the chair and becomes that back support. So it's just one piece of metal in a very clever reorganization of direction. Breuer was really good at identifying what the problem would be and then finding a workaround. As you know, anytime you join tubing, you've got a complicated joint. You have to weld it, you have to fit it, you have to have some sort of joint it fits into. So if you're going to make a small table where a leg needs to join the stretchers, you've got an awful lot of joinery. And here are two solutions that Breuer proposes. On the left, let's just go around the leg. Forget putting a leg on it, let's make the stretcher turn into its own leg. And on the right, the legs could just attach to the top surface and continue on their way without ever having to stop. There are joints in these, but they happen down at the bottom where the tubing is straight. I'm showing these mostly for later comparison and to get you as many Breuer tubular steel things as possible in one lecture, but you can see some of his work is incredibly well considered and figured out. This green chair is just one line of tubing sauntering its way around the whole chair, and then two horizontal stretchers that support that. There's almost nothing in it, and it's a really fully formed idea about a chair. The card on the right, on the other hand, has so many angles and bends and sort of custom, difficult to manufacture components that it is not as successful an investigation. And I show those both because I have things to compare them to later. I also wanted to point out that the triumph of the time was using tubular steel to make a chair. The challenge that didn't really get fully resolved was, what is the seating surface? Is it a very old-fashioned sort of woven seat? Is it fabric? Is it leather? It's some sort of flexible material stretched between the tubular steel. So on one hand, we can charge forward into the modern era of tubular steel. On the other hand, we have to rely on some slightly more old-fashioned techniques of actually holding the person up. Breuer moved to England to escape the Nazis and worked with Isokon, one of the earliest companies looking into how to use plywood to manufacture designed objects. And we'll look at those in a very big way when we look at plywood in 2 weeks. It's very interesting to me, with that chair on the lower left, to look at how Breuer decided to reinterpret his aluminum chair in wood. And it's a great lesson to designers that materials tell you things, and you can't really just translate one material into another. You'll get close, but there have to be some sacrifices. And I think that although this is a triumph of plywood manufacturing, it's incredibly, incredibly difficult to manufacture because the seat and the arms are very hard to join together. And it was sort of a desperate attempt to reinterpret his aluminum chair in wood. I think it's really interesting as a design exercise and perhaps less successful as an actual design, but I love seeing how Breuer's investigative spirit is just transferred to the material that's available where he is. And in 1937, he moves to America also to teach at Harvard. Another person we need to look at the time is Mart Stam, and he's Dutch. He moves to Berlin and participates in a Bauhaus show in 1926 where he made a classic mistake. He had a great idea and he shared it with his friends. You know what happens when you do that. On the left is the proposal that he had. We can eliminate the back legs. We could introduce the cantilever, an idea that was important in architecture as well at the time, into furniture. Metal tubing is strong enough that just the front legs are enough to hold a person up. That seems like a small idea to us today, perhaps because we live in a post-cantilever world, but at the time, a chair with no back legs was radical. And you can see he didn't actually make a chair. He took plumbing parts and screwed them together and made a proposal, a structural suggestion. And on the right is the actual chair version of that, made out of tubular steel and plywood. What's interesting about this story is that, of course, the person we think of as the person who introduced tubular steel furniture is Marcel Breuer. Mart Stam ended up having to sue Marcel Breuer for copyright infringement because he invented the cantilevered chair and Marcel Breuer had made a cantilevered chair. What's interesting is the judge resolved the patent suit by awarding Mart Stam the right to call himself the inventor of the cantilevered chair, and Marcel Breuer got the right to call himself the man who introduced tubular steel furniture. So they each got a part of the early claim on this important innovation, and not the whole thing. They had to share that honor. I think it's very interesting to look at how the Mart Stam chair changes over time. And you'll notice a familiar name if you look at the credits on all these slides. Who's making the furniture? The Thonet Company. Those are the people who made the incredible steam-bent chairs from the 1840s on. If you live in Europe at the time, in Germany especially, and you have a material, this new material, tubular steel, that requires it be bent, you can do that in a shop. You all know how to do that with a diacro bender and some tubing jigs, and it's fussy and it's difficult. Well, Thonet is going to be pretty well set up to understand the fussy difficultness of bending. And with less retooling and learning than other companies would have to do, they were able to manufacture using this new material very successfully. These are all versions of what the Thonet Company sold as the Mart Stam chair, and there are radical differences in them. Here's a slide of 3 of the S43 chair. That's just called the Stam chair. And I hope you agree that if you look carefully, they're more dissimilar than similar. The chair on the left, the earliest one, is very heavy pieces of wood for the seat and the back and on the arms as well. The upper right-hand chair shows a more refined ability to make plywood, but it's still just sort of bolted on through the steel. And the chair on the lower right is the contemporary version, where we've so mastered laminated plywood and countersunk cap head machine screws that we can make something that probably is closer to the vision Mart Stam had, the purity of that design in production, but is actually radically different from the ones being made in his day. And I just put that up as a warning to you. If you did a Google search on Stam chair, you're probably going to find the new one over the old one. And if you're looking for authenticity, you're going to have to use your eyes and your brains in a more thorough and careful way to help explain the history of this one chair. The idea that Thonet was taking over this manufacturing, I think, is very exciting. Here's a catalog from 1931 that shows Breuer chairs in such a great celebration of crazy geometry that you can't help but get excited about this new aesthetic. I'd like to look at some other designers who are active at the Bauhaus and helping to forge this Bauhaus aesthetic. You have a choice. You're at a fork in your road, and you can either call this man Wilhelm Wagenfeld, which is sort of boring, or you can lower your voice and do your best Marlene Dietrich impression and say Wilhelm Wagenfeld, which is much more fun. So I recommend that. Wilhelm Wagenfeld studied metalwork at the Bauhaus between 1923 and 1925, where he designed probably the most famous Bauhaus object, this lamp on the left, with Carl Jacob Zucker. It became one of the most popular, it remains one of the most popular objects from the Bauhaus era. And it's one of the purest expressions of that Bauhaus theory: geometrical shapes, industrial materials, no concession to decoration or frivolity. In fact, it was a little too difficult to manufacture in-house. The plan was make these things and sell them to the outside world and help fund the school. That was part of the Dessau Bauhaus sort of business model. They ended up having to farm this out to an outside manufacturer. The tea strainer on the bottom is electroplate, and that shows, again, using the materials of the day and the manufacturing techniques of the day to arrive at a new aesthetic. I get excited about Wagenfeld's work because he was one of the few Bauhaus designers who actually had a long, successful career in industry, designing for serial production. He worked for Jenaer Glaswerk and many other manufacturers. In fact, we're going to look at his work for Braun Design in the 1950s, so keep his name in your brains. Some of his designs are still in production. You can see the tea service in the top picture at the RISD Museum in the 20th Century Gallery. Just as a side note, it looks incredibly fragile, doesn't it? It looks like if you pick that up and put it to your lips, it will just shatter. And when you see it in the museum, it's as delicate looking. In fact, it's borosilicate glass, something developed at Corning in America. In 1915, Corning introduced borosilicate glass. It made glass objects able to survive a much wider range of temperature. It made it possible for Corning to manufacture glass dishes that you could cook in. You could bake in the oven and then use them as serving dishes and even refrigerate in them. I'm not showing you the objects that Corning made because frankly they're just not that interesting. Wagenfeld was much better at using this new material and figuring out ways to make objects that were really exciting looking and also could perform that exciting new range of functions. Most famously in his Kubus containers. It's a series of, I think, 10 pieces that could stack. There's 7 bases and then top lids to them that could stack in each other in different combinations. So you could bake in them and serve in them and refrigerate in them. And if you ever see them in an antique store, buy them because they're incredibly valuable now. They were mass-produced and remain one of the most famous objects from the period. This is a mini side story I want to tell you just because in past years of teaching this class we've had different textbooks that tell the story differently. So I did a little bit of homework to make sure I could get the actual facts for you. So next time you're at a cocktail party and your host uses one of these coffee makers, you'll be able to get the story correct. On the left is a clumsy, wonderful American coffee maker by the Silex company. And Silex has a great, I have to consult my notes for a moment to tell you what this means because it's so funny. Silex stands for Sanitary and Interesting Method of Making Luscious Coffee. The Silex Company. It's based on laboratory equipment, and it's a simple premise for making coffee. If you've ever used one, it's like magic. The water boils in the bottom, turns to steam, goes up through the tube, is forced through your coffee grind, and swirls around in the top, making very strong coffee. When it cools and turns to a liquid, when the whole device cools, it gets sucked back down into the bottom part by vacuum pressure and sucks through the filter. So the coffee grounds stay above and the liquid coffee goes below, and then you disassemble it and pour, and really hope that you don't break the parts washing them because they're impossible to find replacements. So that's the Silex coffee maker method. On the right, in the middle, is a famous coffee maker designed by Gerhard Marcks for Sintrax coffee machine, the Sintrax coffee machine in Germany. And you can see, although it's 1925, it doesn't really confidently want to proclaim its 1925-ness. It still has feet that look like they're off a coffee urn. It has feet that look like they're from a piece of furniture with a sort of fancy footed method of meeting the table. It is using chromed metal, but it's, to my eye, not as confidently 1925. And as early as 1930, Sintrax hired Wilhelm Wagenfeld to redesign that coffee maker and welcome it into the new age. And I think it's a triumph of redesign because he's just rationalized the base, used basic geometry and redesigned the handle and made the object more of a celebration of the geometry it's stuck with because of some of the glass manufacturing used in it. So there are three versions of this coffee maker. You'll see the two on the right, the Gerhard Marcks Sintrax coffee machine and the Wilhelm Wagenfeld one, confused for each other, and oftentimes given both people credit for either of them as a lazy way of solving the problem. So that's more time than we should have spent on that, but I thought you'd like knowing. This is an interesting Wagenfeld design. This is the contemporary version. It's still in production by Technolumen. I'm not certain who made it in 1930. Perhaps that company was around then too. I'm excited by this design because it has everything you want from a Bauhaus era design. It's purity of geometry. It's a symphony of sort of cylinders and discs and rods, and it's chromed and shiny and no decorated surfaces, and yet it can work as a table lamp. It can light upwards or downwards. It can be mounted on the wall and point up or down or out, and in each of those positions its form changes. That's always interesting to see something that can manage to maintain its sort of purity of concept in use and satisfy a bunch of different uses. Another Bauhaus designer who found success in industry is Marianne Brandt. She's also important because she is a woman working in one of the shops at the Bauhaus where women were not initially allowed. The Bauhaus, although forward-thinking, still had some sort of old-fashioned ideas about where women could be. They could be in the ceramics studios, they could be in the weaving division. Marianne Brandt broke down those boundaries and charged forward into the metal shop, where she was so adept that she became the workshop's director in 1928. She negotiated contracts between the Bauhaus and outside industry for collaborations in metal. And that experience left her better prepared to work in industry when she left the Bauhaus. She lived to be 89 years old and had a long career designing. Her most famous objects are still ones she made in the Bauhaus period. On the left is a copper version and a silver plate version of her famous teapot, which is now called the model MT49 tea infuser. One was sold recently for almost $400,000. They're remarkable objects for a long list of reasons. I hope you'll agree that the handle isn't something you'd really enjoy picking up and pouring from. The ergonomics are not considered. But if you ever want to understand how to assemble geometry into a functioning object, look more at Brandt's work. These are some lamps that she made which celebrate everything you would want in a Bauhaus design. The only surface decoration is the marks on the aluminum from the spinning process. A sheet of aluminum is put over a spinning mold, and it's condensed around that wooden form. As a result, you get these radial sort of scratch marks in the surface, and rather than polish them out, they're left as evidence of the simplicity of manufacture of these lamps. Many of these are still in production as well. They're unapologetically geometric. There is no decoration. These are more pieces she made in the Bauhaus metal shop. They're ashtrays, and again, they show a really successful combination of basic geometry using very simple materials, brass, nickel-plated brass. On top are silver-plated teapots, a teapot and a, I guess, coffee pot. No, that's not a coffee pot. I think it's a creamer that she made in the Bauhaus metal shop. And on the bottom are the Alessi versions that were put in production more recently in stainless steel. You can see, or I will tell you, the difference between a silver-plated object and stainless steel. What's interesting to me is the basic simplicity of construction allows these to be made later in a totally different material and arrive at the exact same aesthetic. The only difference is the color temperature of the metal. Brandt went on to work in production, and the lamp on the left is one of her more famous objects because it was produced in such large quantities and was relatively inexpensive. It's made out of humble materials. It's just steel and then some enamel paint. I know very little about her work for Rupelwerk. These are some objects of things she designed, and I'm not showing them because they are the most important objects I could show you, but they do show her ability to arrive at a really fully formed aesthetic with very few materials. And I think when we look at Brown design and the very rational approach to design that happened in the 1950s and 60s, this clock, a good 30, 40, 50 years earlier, could fit in just as well then. And I think it's always exciting to see something that far ahead of its time. So keep that clock in mind. There are many other designers working in Europe in the same vein, at the same time, exploring the same explorations, who are less connected to the Bauhaus. And I want to look at them as well as evidence that this conversation, how can I take new materials and arrive at a new aesthetic? How can I create objects that speak to manufacturing and quantity, even though at the time they're not taking advantage of that? Mies van der Rohe is certainly somebody we need to look at in that conversation. He worked for Bruno Paul in 1905. He worked for Peter Behrens in 1908 with Le Corbusier and Walter Gropius, and then he opened his own practice in Berlin in 1913. So he's going to take architecture into the modern era, and he's bringing a lot of expertise from the past era with him because of all the places that he worked before he set off on his own. He was the president of the Deutsche Werkbund from 1926 to 1932. We looked at that a few weeks ago. The Deutsche Werkbund was sort of a matchmaker between designers and industry, trying to get artists and designers working for serial production. So he's already interested and versed in that conversation. He was the last director of the Bauhaus in Dessau from 1930 to 1932, and in 1938 he came to America, where he headed the architecture department at the Illinois Institute of Technology. I like looking at his tubular steel furniture because it shows me that he's trying to solve a different challenge. He's also making a cantilever chair, no back legs, but he's, instead of using sharper 90-degree bends, looking at long, gradual, relaxed bends where there is really no front leg. The bottom surface turns into the seat surface with a big curve. That's a different manufacturing technique. That's rolling the tubular steel instead of bending it on a diacro bender. These chairs have been in production since they were designed. For me, that's also always an interesting part of a story. Because I'm sneaky and I want to force you to look at as many women working at the time as possible, I'm going to talk about Lilly Reich here. She worked for Joseph Hoffmann in Vienna in 1908, so she's also well versed in old school architecture. In 1912, she joined the Deutsche Werkbund, and in 1920 became its first female director. That's sort of radical, that in 1920 a female architect designer is interpreting the conversation between design and industry for the world. And she realized that education was a big part of what the Werkbund should be doing. She planned and curated several design exhibits that traveled around to promote German design. One of those traveled through America. It was at the Museum of Art in Newark, New Jersey, where thousands of German objects were on view for American artists and designers to look at and learn from. That's going to really inspire new ways of thinking in America, which we'll look at in a moment. In 1926, she moved from Frankfurt to Berlin to work with Mies van der Rohe, and they were professional and personal partners for 13 years, from 1925 until he emigrated to the United States in 1938. These are chairs that she made on her own, and you might argue that they're very clumsy affairs. There's lots that isn't quite as resolved as it should be, but it shows you that she's designing furniture using all the same sort of investigations as everybody else. It's interesting to note that Mies van der Rohe did not make any furniture before he met Lilly Reich, and after he left and came to the United States, he never made any more furniture. She, on the other hand, designed furniture throughout her career. So I think it's sort of interesting to see, I have a few examples today of people whose work was improved through collaboration, and I would argue that van der Rohe's furniture is certainly in that category. I also like looking at how the same concept of chair is tweaked to suit different materials. The chair on the left is tubular steel, painted in this case, not chromed, and again, a woven seat because we don't quite know what to do about the seating. The chair on the right is bar stock, so that allows for a different kind of bend. You can make a more extreme bend, and it can support weight in a different way, so the attachment points can change. But it's essentially the same idea about a chair. Another architect doing important things for design, industrial design, is Le Corbusier. He's a Swiss-French architect and designer, and perhaps the most important pioneer of modern architecture and the international style. He was dedicated to providing better living conditions in crowded cities, and I'm going to mention that in a weird way later and get myself in even more trouble than I'm in already. He had a 50-year career, long career, and designed buildings all around the world. He's not part of the Bauhaus, but he is same story, same time, same interests, same success. So we're going to look at him. And this is the pavilion that he designed for the Paris Expo of 1925. We looked at that last week, and remember I showed you department store pavilions. The problem with this lecture is I'm not editing this at all. There's no time. This is hurricane damage lecture, and I'd love to go back and edit this audio and get rid of all the stupid things I'm saying, but if you've made it this far, you're going to laugh at the idea that I'm just having to swallow my pride and let this be stupid. So I'm about to say that last week I showed you pavilions for department stores at that exposition and talked about how interesting it was that commerce was on view in a way that it hadn't been in previous shows. The 1851 Crystal Palace exposition had pavilions by country. Suddenly in 1925 we had commerce. We don't need to relive that memory, but remember, if you can, the slide I showed, which had the 4 department store pavilions that all looked like weird Smurf huts or thatched roof follies of some kind. Well, this incredible building was at the same show. So that was a very long backpedaling to try and get you to remember the aesthetic of the 1925 Paris Exposition, because this building, the Esprit Nouveau Pavilion, and remember, the show was a call to designers for things that were forward-thinking, that were new, that were unapologetically modern. This building is unapologetically modern to the point where people were quite confused by it. We're not here to talk about architecture, so forget about that. But look closely at the picture on the right, and what do you see? Thonet chairs. You can see one on the right, at the desk, at that little table, and then you can see a forest of legs peeking out from behind that display case in the center. And then the chairs you can see in the front are just kind of boring leather or velvet-covered club chairs. Nothing unapologetically modern about any of that. It's important to know that Corbusier could invent a modern look for buildings, for architecture, but when faced with the interior, he suddenly ran into a sort of a wall. He realized there wasn't a modern expression of interior components, of furniture. So why am I showing you this slide? In 1926, Charlotte Perriand was a designer in Paris. She had work on view at the Paris Expo as well, interiors that look like these two slides, other of her work. And you can see that fits in more with what we looked at from that show. It's got all the things you want from Art Deco. It's geometric. It's got sort of a luxurious celebration of surfaces, of glass and of wood and of upholstery. But it's not very forward-thinking. It's not very modern for the time period we're talking about today. It works just fine for 1925. But what we see by 1927 in this great bar under the roof is a completely different Charlotte Perriand. And there she is on the left. I put this picture in just because it will help you understand her personality. What does she do when she gets to the top of the Alps? She greets the Alps this way. So how can you not fall in love with a woman who's got to flash the Alps? Refocus your attention for a moment to the picture on the right, and you can see a completely new aesthetic. It's tubular steel, it's chrome, it's shiny surfaces, but it's lost the sort of enslavement to geometry that her earlier work had. She's someone to keep your eye on. And by 1928, she's designed an entire interior for another interior decoration show. Here's a review from a paper called The Studio of this exhibit. Perhaps never before have I so definitely experienced the feeling of entering a new world, of breaking with narrow traditions, be they ever so respectable, of a window open to the future. The motor car, the airplane, and wireless have in a few years revolutionized the material conditions of life. Grave social questions, home life, housing, the position of women, have altered our customs. At this time, the artists have not remained outside the movement. They've progressed with it, and sometimes even gone beyond it. It's very easy to see in this illustration by Perriand and this picture of the chair from that exhibit how that interior could inspire that review. Here's the prototype chair on the left and the production version made by Thonet on the right. I have a few before and afters to show you to help you see that these prototypes were very homemade affairs compared to the slightly more refined Thonet versions. When Corbusier sees Perriand's work, he sees these interiors and realizes this is a better approach to a modern interior. Thonet chairs don't belong necessarily as the only furniture in my interiors. We should be making our own furniture to celebrate on the inside of the architecture what the outside of the architecture is already achieving. In 1927, Corbusier hires Perriand to come on board as a designer of interiors and furniture for his firm. She works along with Corbusier and his cousin, Pierre Jenaer, and they do a thing that I'm sure all of your friends who are architects do. So anyone who's an architect, stop listening for a moment. Architects love to talk. And what they did was they talked, and they talked about the 3 positions that your body should be held in when seating. You should sit upright when you're paying attention. You should be a little more relaxed when you're paying attention, but to something more fun than a business meeting, and you should have a way to lie down in your seating as well. So upright, reclining, and really reclining. I'm sure there's a better use of language to describe those three positions. But what happened is that they kept talking and talking, and they drew up these 3 positions, and they kept talking and talking, and when they were done talking, they talked some more. You know how this happens with designers. And Perriand got a little frustrated by this, so she went to her metal worker, who had made her other furniture, and had him fabricate the prototypes of each of the 3 positions that they had been working on and sketching, and installed these prototypes in her apartment, and invited Corbusier and Jenaer to come over. When they walked in, they were reported to have been astounded that there were the physical manifestations of all of their talking and thinking. There was the siège à dossier basculant, the chair with the tipping back, the chaise longue, the reclining chair, and the fauteuil à grand confort, the very comfortable chair. I hope you'll agree that that chair looks not only very comfortable, but remarkably unlike the version you thought I was going to show you. These are 3 different versions of the most famous chair from this exercise. The original, I believe, is the upper right-hand side without the leather, and it's just a sack of feathers. It's beanbag chair meets tubular steel. The chair on the left is the slightly more finished, leather-clad prototype. And then the picture on the lower right is how we know that chair looks today. So whenever we talk about Le Corbusier's chair, that's the one we think of. In fact, that wasn't possible until we had foam in 1965. Expanded cell foam in 1965 allows a perfect rectangle of cushion in a way that wasn't possible before. I hope you will all, when looking at this chair, come to the conclusion that a chair with a tipping back is not a good idea. If you've ever sat in one, you know that it never gives you any fixed support, and it oftentimes pinches you in ways you wouldn't want. I hope you also look at this and realize that they made the mistake of realizing a prototype and never going back and refining it. If you're using tubular steel and your goal is to make smart production, to avoid welds, to avoid cutting the steel, to avoid having too many connection points, this chair is a triumph of aesthetics, but a tragedy of manufacturing. It has more welds, all hand-fitted, hand-welded, cleaned up, hand-polished, and then chromed than any chair could ever have. That's the reason, perhaps, that this is the least evident of the 3 of them in today's world. You don't see this one as much. This one, again, its original form, and its more manufactured form later, using foam, has been in production pretty much ever since. As a result of these 3 chairs, Corbusier became very well known for his furniture designs. He introduced the tubular strike that, delete that if you care to. He introduced the tubular steel ideas of the Bauhaus to France, and also interpreted those ideas in a slightly more sort of French way to suit his own needs. He did at the time credit Perriand for setting down the design parameters and the basic form and then working on the details and the execution. It isn't that he claimed credit for these chairs, but because of his enormous reputation, for many, many years, all of these chairs were just described as Le Corbusier's furniture. Over time, that attribution has expanded, and now they're generally credited as chairs designed by the team of Corbusier, Perriand, and Jenaer. Because I've introduced the concept of Charlotte Perriand and the exciting flashing of the Alps that she managed, I want to talk a little bit more about her, because she doesn't really fit anywhere else in our semester, and a lot of her interests take us where we want to go. She was very frustrated by the expensive price tag on this furniture, and by the reality that most people weren't able to or interested in welcoming it into their own homes. It was too radical. She also was interested in designing for the masses, for everyone. And it's interesting to look at her work as a result and see how she extracted some of the components of what we're talking about with the purity of the Bauhaus and European design aesthetic and made it a little more consumable. These are chairs that she designed to fold and stack. I don't know the history of the beach chair well enough to say this is the first beach chair, but definitely it's removing everything extraneous, keeping the tubular steel for its manufacturability and its price, but adding a comfy upholstered cushion so that it's a little more comfortable. She's also proposing a different use of space. She's proposing that in our homes we lower all of our surfaces, we make things more flexible and modular and movable so that we can have furniture that suits our own interests in living in our house, rather than have a designed aesthetic that doesn't really support our lifestyle. She also is interested in how to recreate that modern aesthetic using more familiar or warm materials, using wood, using fabric. In 1941, she worked as an advisor to Japan's Department of Trade and spent some time in Japan. And I just include a few slides of her work from that time period because I think it's interesting to see how any designer uses new material to arrive at a hybrid of their design interests and what the material will allow. This is a very simple bed that she designed out of bent bamboo. And here's a chair she made while in Japan. It's a folding chair, very much like futon chairs of today, and I like seeing that it's an effort to combine two of the three seating postures that she had helped identify, the sort of relaxed upright and then the reclining seating position, but using just one chair, so more flexibility. You get more for the money you spend on this chair. And perhaps most fascinatingly, she went back and revisited the chaise longue from 1929 in bamboo in 1941. It's the exact same chair, radically different material, very much like Marcel Breuer designing his aluminum chair in plywood when he got to England. In 1950, she published her own manifesto called The Art of Living. She was very interested in the idea that design and living should be joined, that you can design objects, but you can also design your life and your lifestyle, and the object should help you do that. She designed whole programs for ski resorts, for hotels, for public spaces, where the populace, where the masses would encounter design. As a result, many of her objects are very sturdy because they're meant to be used, and in many cases sort of disappear into the background of use. This is an early closet system where the components can be assembled in different ways to give you the most amount of closet in the least amount of space with the least amount of stuff. We'll look at a bunch of different closet systems in the 1960s, but she's doing it quite a bit earlier than other people. And she designed the kitchens for Corbusier's Unité d'Habitation in Marseille, an important piece of architecture that's a large, low-cost housing project. And all the things we looked at in terms of kitchen design in the efficiency era, trying to figure out circular motion and compactness of space, are things that she considered in this kitchen design. She did a lot of work, as I mentioned, for ski lodges, for hotels, and I think it's just really interesting to look at how her work is a hybrid of use and aesthetic. How much sculptural form she gets out of something and still have it be a pretty basic object. In that vein, probably the greatest triumph of her work is the ombre chair, also sometimes called what is it also called? It has another nickname that I can't remember and isn't in my notes. It was designed... I'm a failure at this job. I wish you could know that I'm sitting in my kitchen right now and there's a hurricane outside, and the amount of noise, I'm sure you can hear it. The refrigerator just clicked on. Anyway, back to Perriand. She died in 1999 at the age of 96. I think if you look at the ombre chair, you get everything you need to know about her, which is that she was great at interpreting material limitations. She was great at creating objects that were sculptural form, that were exciting to look at, that change as you move around them, but that also satisfied functional, practical requirements. I know nothing about the Luckharts, but I'm going to talk about them anyway. This is my charging forward into ignorance. I hope you agree with me, in wood, their designs are not a triumph. This is a chair produced by Thonet that doesn't take advantage of any kind of bending or smart manufacturing. It is a lounge chair like any number of others, and on the left you'll see a folding chair, again, manufacturable, consumable, sittable, onable, but not all that interesting. And on the right, when they switch to tubular steel, their aesthetic is somehow mysteriously fully formed and I think very exciting. I showed you, without talking about it, Marcel Breuer's table earlier that was essentially bent tubular steel, a filing cabinet, and a top surface screwed together to make a really beautiful expression of Bauhaus aesthetic. This is another version of that same exercise done a year or two later. The fewest number of parts to make a pretty radical, complete object. And here's the real triumph. This is the Luckhardt chair. It's like the second generation of tubular steel. They're taking what Breuer figured out, what Mies figured out, and combining all of that and making something that is sculpturally one of the most exciting chairs ever made. And from a manufacturing standpoint, one of the biggest nightmares ever produced. This is using every way you could possibly use to bend tubular steel. Some of it is rolled, some of it is bent in a jig, some of it is bent on a diacro bending machine. All of it is hand assembled. All of it is very hard to match to a drawing and then welded together and cleaned up and chromed. The chair is cantilevered on very small welded steel brackets, and the laminated plywood pieces are made in a way that you had better hope they don't spring back too much when they come out of their mold, because they have to fit inside this tubular steel. So everything about this is very, very hard to make, which made this chair very expensive. So huge fail in terms of ease of manufacturing. In terms of using manufacturing as a way to understand and arrive at form language, total fail. As object, incredible success. And as expression of purity of concept, which is something architects love to look at, really, really successful. So why am I putting it in if my focus is always on understanding manufacturing as an important tool to designing successfully? I'm putting it in because look what happens when America decides to start chasing this same dream. I think that chair on the right is one of the ugliest things ever made, and my apologies to the family of Nathan George Horwitz, because I not only know nothing about him, I have decided not to learn anything about him because I have such a visceral reaction against this chair. But, and this is a really big but, Matthew has a really big but that chair is really smart manufacturing because the top and bottom chrome parts are the same. Because the weld joint on the top is hidden under some upholstery. There's almost nothing to this to make the chair. And I will forgive Nathan George Horwitz the clumsiness of this chair because I so appreciate his desire to make this aesthetic manufacturable. We're going to switch into phase 2, which is what happens when America, and remember, we're really good at manufacturing. We can make Model Ts like nobody's business. We can manufacture things because we understand manufacturing, but we don't at this point really understand pretty very well. We don't have control over the aesthetic of what we're making because we're so focused on making it in repeat. It's like the Bauhaus started with handmade things and we're struggling towards machine manufacturing, and America was starting at the other end of the extreme, machine manufacturing, struggling to get towards an aesthetic, and we're going to meet in the middle. So I hope you will forgive the Bauhaus for not thinking about manufacturing because that wasn't their exercise so much, and I hope you'll forgive all the stuff I'm about to show you for not being as attractive as it might be, because that was not necessarily the exercise. The important thing to know is that when the Bauhaus comes to America, it does so in a way that's radically exciting. Macy's had a show called Art in Trade, sponsored by the Met, in 1927, and it's the first large department store exhibit in New York City to showcase modern American design. There is a desire in America to move forward in design, and what's interesting is Macy's realizes that we'd better get a museum involved to make sure that happens correctly. Over 50,000 people came to see this week-long show. There is a really strong desire in America for modern design. There just isn't the right equation yet. Last week I introduced Donald Desky, and I talked about how he went to Europe to see the 1925 Paris Exposition and came back determined to introduce the Art Deco as a style to America, and how he did so especially at the Radio City Music Hall in New York. I left a little bit of that story out for this week because I think it's so sneaky and funny, and I hope that you as designers will learn from it. He was hired by the Ypsilanti Reed and Fiber Furniture Company to redesign their line of rattan furniture. So listen to that again. Look at the name of this company, Ypsilanti Reed and Fiber. They make rattan furniture. That's what I call Pier 1 furniture. It's just woven stuff. And he takes the contract, and this is a great example of seeking forgiveness instead of permission. He arrived with a whole slew of new designs, none of which were for rattan, all of which were for modern furniture using modern materials. And it was such a compelling example of doing something successfully that the Ypsilanti Reed and Fiber Furniture Company decided to take a gamble on this, change their name to the Ypsilanti Furniture Company, and make something they called the Flectrum line. On the right, you can see the table, one of the tables that they produced as a result of this collaboration. All of Desky's work shows, like Marcel Breuer's did, a struggling to answer questions, and you can look at each one and see the table on the upper left is exploring square tubular steel, because square tubular steel has a reference surface and you can bend it automatically on a machine without worrying about the bends going awry. The price you pay for that is it collapses on the inside of the curve a little bit, and that ruins the purity of the form. The table on the lower left is looking at using bar stock and screwing it in different ways to flat surfaces to figure out how to use one leg as four legs and make a table with two surfaces with the fewest number of parts. The table on the right is so clumsy. It's extruded steel screwed together in different ways. And aesthetically, I don't think it's a wild success, but I love the yearning for manufacturability, the taking materials that are mass-produced and trying to figure out ways to assemble them into furniture. This is a picture from an auction catalog from a collection assembled in 1930, and I found it fascinating because it's taking the Mart Stam chair, produced by Thonet in 1930, and an Ypsilanti Furniture Company table by Don Desky from 1930. The table is not a triumph of the Bauhaus aesthetic, but the chairs are, and an American collector in 1930 realized that combining them got you legitimacy and savings all at once. I know that 3 people watching this, if 3 people are even still watching this, which I sort of doubt at this point, are groaning because could these things be any uglier from our point of view? But I ask you to consider that the chair on the left, again using square tubular steel, which is easier to, you don't have to fit the welds, you can just cut and weld, and you can bend them with a reference surface. And the chair surface is what we now call naugahyde. That's because polyvinyl chloride, PVC, is a brand new synthetic, initially as an adhesive, and it turns into a coating on fabric, and you get this miracle material that isn't leather but looks like leather. Again, high-end aesthetic, low-end material. And on the right is another new material, which we now call, well, it's a laminate. It's called formica. And that's originally made as an insulator on cabling, on wires, but people realize you can make a flat surface out of it and put patterns. I would argue that in this case the pattern wasn't worth putting on the formica, but you can see that these are brand new materials being used by Desky because they can achieve manufacturing savings without sacrificing quality of product. Another designer I'd like to look at is, you can also call him Kem Weber, or if you want, because you know he moved to America from Germany, call him Kem Weber. He came to San Francisco in 1915 to supervise the German pavilion at the Pan-Pacific Exposition in San Francisco. Any of you who have been to the Exploratorium, that's the campus of that exhibit, still there. And he got stuck here during World War I, and thank heavens stayed. He's trained as a woodworker, and I think it's really interesting to look at his transition into metal. These are wood chairs. The chair on the left couldn't be working any harder to look like it's made of tubular steel. The chair on the right is a chair I've always hated because I think it's just so clumsy. It's often called the airliner chair. It I fell in love with it last year because I realized not only is it doing cantilever in wood, because that was the material that was more available to him, but it is a knockdown piece of furniture. It's designed to come out of a box, and that made me forgive all of its clumsiness because it's arriving at cantilever in a material that doesn't really want to be cantilevered, and doing so in a way that allows mass manufacturing and easy assembly. But what happens when Weber switches to chromed tubular steel is a huge sacrifice of aesthetic. I think he makes among the clumsiest things made at the time period, but again, the striving for manufacturability is really interesting to look at. The chair on the left is the same part used twice for the arms. The ottoman on the right is realizing that if you bend the tubular steel out, you get more visual weight at the bottom. If you add more rows, you get something that references Art Deco streamlining and speed whiskers, but it's just the same part used 3 times. He's exploring where tube steel can be crimped and then bolted onto itself, where you could wrap wire around it. There are all sorts of manufacturing explorations happening in these objects. So I will give them some leeway aesthetically. I also like seeing that one bay chair could be extruded on one axis and turned into a 3-bay sofa. And the piece on the right, like the Luckhardt chair, is bending tubular steel in all sorts of irrational ways, but you can see it's also doing it in a way that's way less careful, way less considered. There's lots of room for error in this because it kind of doesn't matter. We'll just disguise it by putting some lime green around it. As a contrast, here's the green chair from Marcel Breuer that I think is doing the same thing in a really elegant way. So there's a good example again of Bauhaus purity. Here's another chair that Weber designed, and again you can see some concessions being made. The bottom of the chair is bar stock, which can hold the weight of the chair and the cantilever better. The back of the chair is crimped tubing that's just screwed on. You might think it's a hideous chair, you might think it's an attractive chair. I'm talking outside of aesthetic because I think it's fascinating to look at the struggle to figure out manufacturing plus tubular steel. Here's a combo slide of the Marcel Breuer desk, the Walter Dorwin Teague desk that we looked at a few weeks ago, and also Ken Weber made a desk in the same style. I should have put the Luckhardt's desk in here as well. This idea that filing cabinet plus tubular steel equals modern desk is a really interesting one to me, and I would love to know how well known the Breuer desk was. It's 2 years earlier. Did anybody know about it? Is it possible that all designers at the time arrived at this formula because it's such a successful one? I've shown you some clumsy explorations. I think there's one designer who really figured out manufacturing plus a more modern aesthetic equals a new direction for design, and that would be Gilbert Rhode. He began his career as a commercial illustrator in advertising. He worked freelance for ad agencies and large department stores, drawing furniture and drawing interiors, and as a result, he really understood marketing as part of the design process. He took a 4-month trip to Europe in 1923, so he wasn't there for the Paris Expo of 1925, but he visited Paris and he went to the Bauhaus in Germany. He actually went and met everyone there and looked at what they were doing right at the beginning in 1923. And he returned home determined not just to become a designer, as we saw so many early industrial designers do, but determined to become a designer of modern goods. He worked for a company called Heywood Wakefield, which made wooden furniture. Although you might argue that these chairs are desperately trying to be metal furniture, they're wood. And a review in the Chicago Tribune of this line of furniture noted that the appeal of Rhode's modernism was its conservatism, that it was not radically different looking. And the review said, nothing he does is startling or bizarre, which might sound like an insult, but in fact they're pointing out that Bauhaus furniture was so unfamiliar that you wouldn't want to mix it with grandma's furniture, and most people had older furniture. Whereas Rhode's furniture you could mix in with any other style and it would welcome the new age, but not in a sort of offensive or startling way. These were also inexpensive pieces of furniture. There were over 100 pieces of furniture in the first Heywood Wakefield line that Rhode designed, and they sold for $6 to $35, depending on the table, buffet, chair, armchair. Very inexpensive, and as you can see, 25,000 of this chair were sold in the first 9 years of its life. Here's a funny little aside. Prohibition is something we talked about last week. Remember that this is also the era of Prohibition. Here's a Gilbert Rhode designed little occasional table with room for books. And then when no one was looking, you could rotate those books out of the way and get to the liquor and the glasses. That has nothing to do with anything. I just wanted you to see it. Rhode also, like Desky, realizes that tubular steel is a material that can lead to a new aesthetic. And interestingly, he approaches a company called Troy Sunshade Company. That's an umbrella manufacturer, because we don't have Thonet in America. We don't have people who know how to bend wood and can transfer those skills to bending metal. We have people who know how to bend metal and just don't know what else they can do with that. Interestingly, also, Troy Sunshade Company has offices throughout Europe because they sell their umbrellas around the world. And those showrooms might have shown Rhode's furniture. I love the idea that Marcel Breuer might have seen Gilbert Rhode's Breuer knockoffs in sales offices in Europe. But Rhode's among the first American designers to use bent metal for furniture, and I think he's the best at it. I think these chairs get as close to Bauhaus credibility and purity of form as we could get at the time, and yet they're really designed from a manufacturing standpoint in a way that other furniture wasn't. Again, you can look for evidence of decisions being made. Where will I, if I'm going to introduce a weld, which exponentially increases cost, where will I do that? How will it be cleaned up? How will I attach the components? As you can see, some of Rhode's designs are really successful. Some of them are more explorations. I think these stools are about as much form language as you can get from pretty simple bending techniques. And here's a comparison. Remember before I showed this Marcel Breuer tea cart, although it's beautiful, it is a very complicated thing to make. Very expensive because all of the bends are particular angles. It has to be assembled before it can be chromed. Very complicated object. The tray on the right, I think, is borderline hideous. And I'm not able to talk to Gilbert Rhode, so I don't know, but to my eyes, it's more an investigation of how can I use the simple process of manufacturing that Troy Sunshade already has in place for their umbrellas to produce furniture. Because it's chromed steel and plastics, it can go outside. So, ugly as it may be, I really admire the fact that it's looking for ways to make new objects using pre-existing manufacturing techniques. And with the Marcel Breuer object, beautiful as it may be, I have a little bit of a problem that it's not considering that. So this is just another one-slide support of this idea that we're trying to meet in the middle and get these two things to work well together, beautiful aesthetics and manufacturing, and right now we're not quite there. Because I like to show you drawings, there's a beautiful gouache painting of Gilbert Rhode's. And I also like that every time someone has a new material, they make a piano bass out of it. Here's Gilbert Rhode's tubular steel piano bass. And again, he's really prolific because there's so much demand. So many people at this time are looking for inexpensive furniture, are looking for a way to express themselves in the new modern style without breaking the bank. And Rhode is able to meet that demand by being extremely prolific. All of these objects were manufactured and they were remarkably inexpensive. The amount of furniture you could get for the money you were spending, I think, was a pretty good equation. So I might not like each of these, but I think they're sketches in service of looking for the right way to do it. Where Rhode starts to really make sense is when he switches from a freelance designer working for Heywood Wakefield to the design director at Herman Miller. The picture on the right shows Rhode's furniture design for Herman Miller, and you can see at a glance that it's a series of components used in multiple repeats to create different furniture. We're going to look at how he arrived at that. The pictures on the left are Herman Miller's catalog from 1932. At the time, the company was on the brink of going bust. They had fewer than 100 employees. They were $30,000 in debt. And Gilbert Rhode had gotten in his car to drive west with his portfolio looking for work. That happy combination left Herman Miller Company thinking, well, we might as well take a chance on the modern style on this guy. We got nothing to lose. And Gilbert Rhode saying, well, I've just tricked them into hiring me as a designer, so that's super exciting. And it's one of the best fits that we see in design and manufacturing in America. Within 6 months of the introduction of Gilbert Rhode's new designs, their losses are down to $10,000, and they're incredibly successful with this new modern style of furniture. The picture on the left, if I asked you to identify a style for this stuff, I hope you'd have trouble figuring that out. It's sort of French, it's sort of colonial revival, it's sort of pretty, maybe it's a little Art Deco. It's not quite a bunch of things. The pictures on the right can only be described as modern, as undecorated, as sort of a triumph of combination of geometry and upholstered surfaces. All of Rhode's work at Herman Miller took advantage of what Herman Miller was really good at. It's a furniture company. They make case goods. They can make drawers and rectangles. And he looked at ways to add a couple of other elements to make that equation more exciting. The Chicago Tribune wrote about this work, a chair, a table, or a chaise longue of his design would fit into a room done in any period of informal type. So they're pointing out that it's not the style that is the limiter. It's sort of, if you're living in your home in an informal, casual way, any of this stuff will work. Many of these pieces were in production for 5 to 10 years, which for a large furniture company is remarkable. And I feel, in looking at Gilbert Rhode's work for Herman Miller, that he is arriving at a comfortable hybrid of an investigation of geometric purity, of formal simplicity, but also manufacturability, low price, and sort of acceptability in your home. This isn't furniture just for the affluent, it's for the growing middle class. I also like that he's just doing the slightest interventions. I'll put a little bit of chrome tubular steel there and a circle of mirror. Attach that to what is basically just a rectangle of drawers, and you have something that has a lot of form language. He's also letting the wood make the piece warm and sort of welcome in your home, and using the tubular steel to give it just a little bit of modernity. And I think that combination is really successful in Rhode's work. As fast as by 1939, so just within a few years, you get the full-blown Rhode style. It's confident, it's refined, it's production-oriented, and yet it doesn't look necessarily machine-made. It has that vibrant surface of wood veneer, and you can see the inside is a rationalized system of components. The whole approach to furniture at the time at Herman Miller was to make these components that could be combined in different ways. With fewer parts, you get exponentially more finished products. That's an idea borrowed from Bruno Paul that he called combination furniture. That's not a new idea. That's Bruno Paul in Germany. But Rhode calls it unit furniture, and it's part of the foundation of what makes Herman Miller so successful at the time. I also like looking for evidence of shared parts. The chest on the left and the chest on the right have the same drawer pull, used in dramatically different ways. It's like Rhode's looking for what's the maximum amount of effect I can get with the least amount of stuff. The chest on the right is just alternating the direction of the veneer, and you get this great checkerboard pattern. And if you just move the drawer pulls into this chevron shape, you get something that's a celebration of the modern style with no more components than it needs just to exist. This is a table that I don't care to look at because I grew up in the post-this-table world of barking my shins on the edge of these tables covered in duct tape to keep you from chipping them. But this basic idea, flat piece of glass with a couple of holes cut in it and the same leg and repeat that screws on when you get it home, it's a flat pack, easy to ship, very easy to manufacture table that creates an aesthetic that I grew up with, so I don't like, but I can't argue that it's not a really fully formed aesthetic that was very new at its time. Really smart combination of manufacturing and design, and the right amounts of each. Rhode also realized that if you were going to sell people new objects, you had to explain those using marketing. We're going to look a lot more at lifestyle marketing when we talk about Russell Wright. I love looking at this picture, though, that shows a cart on the right. On the left, the more important image is the cart in use. And I like that the hostess is facing us. Both of the guests have their back to us. So as a viewer of this image, I'm invited in to have tea with them. Rhode realized that if you didn't, showing the entire interior was one way to get people interested in the aesthetic. You could imagine your home looking like that. But even more so, showing it in use allowed you to imagine yourself using it. And as a result, you get excited about bringing it into your home. Just so you know what happened to Rhode, he died quite young. He died at the age of 50. And that cut short his career at Herman Miller. We'll look at how George Nelson picked that up and took the company somewhere different. But he was very interested in new materials, and before he died was able to participate in the introduction of plexiglass in an interesting way. The 1939 World's Fair, which we looked at last week, was a celebration of the future and had a lot of information about new materials. Rhode designed the introduction of plexiglass for Roman Haas at that show. His exhibit showed how it could interpret light and how it played with light in an interesting way. On the left, there's a sort of crazy exhibit he designed where Mrs. Modern appears from the sky and places a telephone order for her dream home, which arrives on the stage one thing at a time with push-button convenience. And here's a chair that I showed last week as well. It's molded plexiglass and tubular steel. I show it just, it's not my favorite design, and it didn't go anywhere because plexiglass was reserved for World War II bomber nose use and more important uses than chairs. By the time the world ended and plexiglass was available, Rhode was dead. He died in 1944, and so this chair didn't go anywhere. But I think it's just an interesting example of this constant exploration for how do you put a seat onto some tubular steel and get an aesthetic. So there we are full circle. There are definitely sacrifices at both ends of the spectrum. In terms of manufacturability when we make the beautiful objects, and in terms of beauty when we make the manufacturable objects. Because remember, we're in a continuum. We're making a journey towards intentional manufacturing. And we're not able to do it yet, but we're aware that it exists and we should chase it. The next chapter we'll look at is the great American era of form. Around the world, people are starting, for the first time really since the Industrial Revolution, to be able to make, using machines, objects that they've also been able to create with control over their form language. They're sculpturally beautiful, they're functionally satisfying, they're incorporating user preferences and user abilities and ergonomics and marketing and lifestyle into their design at the beginning instead of applied later. It's a very exciting era where we finally get this equation right. And I wanted to stop and talk about the era before in a more focused way to help you see what a struggle it was to get there. Working from a craft-based world into a machine-produced world took a very long time to reconcile. And these objects will help you see when we got that figured out, what we did with it. We're going to take a brief detour next week to look at the birth of the profession of industrial design. I'm going to talk about Henry Dreyfuss and Raymond Loewy outside of the continuum of everything else for a bunch of reasons. Their careers spanned 40, 50, 60 years, and so as a result we can watch the world change as interpreted by designers, single-minded, two designers watching their worlds change and interpreting it for us. Also, the way we practice our profession was developed at that time. By looking at their work, we can see when we started modeling in clay, when we started modeling in foam, when we started using gouache for renderings versus markers for renderings. All of the things that we're learning to practice industrial design were arrived at by practicing designers. And all of those tools are evident in the work of Dreyfuss and Loewy. They're also important designers, and there's a lot we can learn by looking at them in a slightly more focused way. I didn't want to relegate either to a little moment in a bigger lecture. I want to pull them out and talk about them more, but they don't quite deserve an entire week. So I'm using the week to talk about them, but also to layer in our understanding of how we practice industrial design and when all of that happened. So I know this wasn't as much fun as having class. I hope that right now, while I'm sitting in my kitchen recording it, you're out enjoying the before hurricane excitement of terrible weather before it turns into the terrible consequences of that weather. And if anybody made it to the end, I congratulate you. I can't quite believe you bothered. And thank you. See you next week.